Alright, hello math fans. Today we're going to be graphing quadratic inequalities. Alright, so graphing quadratic inequalities. So we're not learning too much new today, and the reason we're not learning too much new is because you already know how to graph quadratic equations. And back in the day, we taught you how to, or I taught you how to graph inequalities, right? And whenever you have an inequality, remember there's two parts to that. You have shading, and the second part you have dotted and solid lines. Remember, if you have a dotted line, it's going to be a less than symbol or a greater than symbol, and the solid line is less than or equal to or greater than or equal to. That's a solid line. So keep that in mind because we're going to have to be concerned about that. And the only thing now different is before I had you guys shade above and below. Well, there's not really an above and below when you're talking about a U shape, a quadratic. You're either going to shade inside or outside. That's the way it's going to work. And you have to test a point. Okay, so let's start out with a real basic problem here. We're just going to do y is greater than x squared. So you have to do everything the same. You're really graphing y equals x squared. Okay, so you have to do everything the same. We have our a is equal to 1, b is equal to 0, and c is equal to 0. So remember, the x coordinate of the vertex is opposite of b over 2a. So it's 0 over 2 times 1. So the vertex is 0 for the x coordinate. And then this one's really easy. Again, I'm starting out with a real basic one so you guys understand it. But you plug it back into y equals x squared, and you get y equals 0. So the vertex is 0, 0. Okay? And remember, it's opening up because a is positive. This value right here, it's positive in front of that x squared. And if I make a t-chart, I have my x and y, and 0, 0 is my vertex. That goes in the middle. Negative 1, negative 2, 1, and 2. So we're going to plug in the 1 and the 2 into there. So 1 squared is 1. That means this is also 1. 2 squared is 4. So that means this one's also 4. All right. So let's make the graph. So it's negative 2, 4. Negative 1, 1. 0, 0. 1, 1, and 2, 4. All right. So remember, it's a U shape. Don't draw a V here. And of course, it's y is greater than. So this one's a dotted line. So it's going to look like this. Okay, that's what the graph is. And now I need to pick a point. It doesn't matter if I pick it inside or if I pick it outside of the graph. What I'm going to do is I'm going to test it. Okay? And if I test a point and it works, it's true. So if I plug a point and it works out, it's like 5 is greater than 3. If that's true, so here, let me write this down. You're going to test a point. So, and if it's true, then you shade where you pick the point. Okay. If it's false, if it doesn't work out, if it's like 5 is, if it says 5 is less than 3 and it's false, then you shade on the point where you didn't pick the point, either on the inside or the outside, depending on where you originally picked the point. So you shade where you didn't pick the point. Sounds a little weird, but you're testing a point. If it works there, you shade it there. If it doesn't work there, you shade it someplace. You shade it outside or inside. So let me give you an example here. Now, first of all, I personally like to pick something on the y-axis. Okay, I like to do that. The reason I like to pick something on the y-axis is because what's our value of x over there? Right? Our x value is always 0. And that's really handy when you're plugging it into a nasty equation. So if I pick something, it's always going to be 0 comma something. Now 0, 0 is actually my personal favorite number, because if you pick 0, it's kind of weird. If you pick 0 comma 0, everything cancels out and you can just kind of test. You can see really easily what's going to happen. But in this case, I can't pick 0, 0 because 0, 0 is right here. It's on the line. That doesn't do us any good. So I'm going to pick 0 comma 2. Okay, and I'm going to test that. Well, let's plug it into our y is greater than x squared. And so 2 is y, so 2 is greater than 0 squared. Well, is 2 greater than 0? Yes, it is. So since 2 is greater than 0, then I'm going to shade where I just picked that point. So in other words, I pick this point right here, and I'm going to shade inside here. Okay. Now technically, it doesn't just end there, right? The line keeps going. So you're shading, you know, it's outside of that, right? You just kind of keep going here, shading. But you just kind of need to shade right inside there. But that's your solution. All right. So let's do that exact same problem. And let's say y, instead of y is greater, y is less than x squared. So I'm going to make the same graph because it really is the same graph. 1, 2, 3, 4. So it's here, 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 and here. Again, it's another dotted line. Okay, I'm going to test this point right here. Okay, it's going to be 0 comma 2. I'm going to plug it in. If it works, then I shade where that point is. In this case, I'm shading on the inside. So I'm going to plug it in. 2 is less than 0 squared, or 2 is less than 0. Is that true? No, that's false. So because that's false, I'm not going to shade where the dot is. I am going to shade away from the dot on the outside. Okay, so I'm going to shade on the outside of this. And it's everything on the outside, just not on the inside. Of course, again, that keeps going up higher and higher and higher and higher. But I only need to do so much shading, okay? So that's your solution. All right, so again, you're testing a point. So people always have a little bit of trouble with this. And let's talk about testing points again before we even do any more graphs. If I have a graph that looks like this, and I pick this point right here, 1, 2, 3, I pick 0 comma 4, and I test it, and I get whatever value, but I get 4 is greater than or equal to 3. Let's say that's what happens after I plug it in. Is 4 greater than or equal to 3? Yeah, okay. So I shade inside here. Let's do that same problem, and let's say it came out to be 3 is greater than or equal to 4. Okay, so it's the same point, and if that's false, which it is, 3 is not greater than 4. Okay, then I don't shade here. Okay, so this is you don't shade here. I'm writing this in, but you're not going to write that on your paper. So you don't shade there, you shade on the outside instead. Okay, so that's the deal. You test a point. Now the nice thing is if you have a graph like this, okay, so the best point to test is 0, 0 because it's an easy point. You plug all the zeros in and everything kind of cancels out. So let's say we got, 0 is less than negative 3. Is that true? No. 0 is greater than negative 3, so I'm going to shade here. I'm going to shade on the outside. You're always picking that test point. Guys, if I would have done that same problem and I would have tested, I would have done this, and I would have tested this point right here, do you think that point's going to be true or false based on this graph here? Well, of course this is going to be true. Whatever this value comes out to be, this is going to be something like 5 is greater than 3. Well, of course, then we're going to shade here. We're going to shade in the same place. So it doesn't matter what point you pick a point, and then you test it, and you see if it's true or not. If it's true, you shade where the point is. If it's false, you don't shade where the point is, you shade outside or the other place where the point is. So it has nothing to do with shading inside or outside. It has to do with shading where you pick that point, the test point. Okay? That's really important you understand that. All right, so let's try a couple other examples here. If I said y is less than x squared plus 4x plus 3. So same thing, you're going to do a is 1, b is 4, c is 3. So x, coordinate of the vertex, x equals opposite of b over 2a. So x equals negative 4 over 2 or negative 2. So it's negative 2, comma, and you put that in there into the equation, you get 4 minus 8 is negative 4 plus 3 is negative 1. Okay, so that's my vertex. Going to make a t-chart. First of all, we know this is going to open up. This is negative 2, negative 1. So negative 2, negative 1, 0, negative 3, and negative 4. If I put a negative 1 in there, I get 1 minus 4 is negative 3 plus 3 is 0. So I get 0. And if I put a 0 in there, 0 is the great number to put in there because the x squared cancels and the 4x cancels and you just have 3. Alright, so let's graph this. Negative 4, comma 3, negative 3, comma 0, negative 2, negative 1, negative 1, 0, and 0, comma 3. Okay, again, this is a dotted line. Not the greatest U shape on here, but okay, now I'm going to pick a point. Now again, this is kind of nice that I can pick this point right here. It's a great point. I know it's on the outside of the U shape. So I'm going to test that one. I'm going to say, hey, is it outside that's true or inside that's true? Okay, so what I'm going to do is I'm going to, again, plug it right into this guy right here. So I'm going to say 0 is less than, the x squared cancels, the 4x cancels, and 3. Is 0 less than 3? Yes, 0 is less than 3, so that means I am going to shade where that dot is, which happens to be on the outside of this graph. Okay, that's my answer. That wasn't too bad. Okay, I shaded on the outside. All right, so hopefully that kind of makes sense. I want to do one more example with you guys, but again, it's all the same stuff of of graph, just kind of graphing it, and making sure you have your dotted line and shading in the correct place. Okay. All right. So here's the last example here. Y is less than or equal to negative x squared plus 6x. Okay, so our A is negative 1, our B is 6, and C is 0. So it's x coordinate of the vertex opposite of B over 2 times A. So it's negative 6 over negative 2, which is positive 3. And then I put a positive 3 into this equation. And again, be careful because it's not negative 3 squared, it's negative and then 3 squared plus 6 times 3. Really important. Okay. Anyway, this gives you negative 9 plus 18. So we have 9. So the vertex is 3, 9. Okay, and if I make a t-chart here real quickly, we have 3 and 9, so 4 and 5 and 2 and 1. Alright, so let's plug a 2 in here. Negative 2 squared is negative 4. Negative 4 plus 12 is 8. If I put a 1 in here, negative 1 squared is 1. That means negative 1. Negative 1 plus 6 is 5. Alright, so we make a graph. We get to make a little more room up here because we're going up a little bit higher. We're going up to 9, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1, 2, 3, 4, 5. It's 1, 5, 2, 3, 4, 5. 2, 8. So we're here, 2, 8. 3, 9. 4, 8. And 5, 5. Now this is a less than or equal to, so it's a solid line. Wow, that's really bad. A little bit harder on the computer here, but yeah, it's okay. Okay, now this is the deal, guys. You don't want to pick. You really don't want to pick 0, 0. That's a really bad number to pick because is it going through it? I don't know. It might be. It might not be. If you pick 0, 0 and you get something like 5 is less than or equal to 5, you don't know what side of the line to shade on. I'm going to pick a point like 1, 2, 3, 4, 5. I know this point right here, which is 0, 5. I know it's outside of this U. Okay, so if I pick, if I plug that in, again, it's easy to plug it in when x is 0. You get 5 is less than or equal to 0 because you put a 0 in there, you get 0 squared plus 6 times 0, right? It goes to 0. Is 5 less than 0? No, 5 is greater than 0. So I don't want to shade where I just put that point. I want to shade on the inside because I just picked a point on the outside randomly. Now I'm going to shade on the inside, and that's what my solution is. Okay? So that's what the deal is with that. All right. If I would have picked something, let's say I would have picked something, you know, way down here. If I pick something way over here, which hopefully that, I don't know, let's say that goes, let's say that's point 0, negative. Let's even do 0, negative 20. Some really number way far down, which I know is going to be on the inside. If I would have picked that number, guess what? It would have worked, which means I shade wherever that dot is. I would have shaded on the inside. Well, let's plug it in and see if it does work. Hopefully it does. Okay, so y is negative 20 less than or equal to 0. Is negative 20 less than or equal to 0? Well, of course it is. It's a lot less than 0. So that's why you're going to shade here on the inside of this parabola. Okay, so that's it. It's just kind of combining some of the other stuff that we've learned already. But you know, just be careful. Solid and dotted lines. Be careful. Make sure you shade, and make sure you always pick a point. Something with a x value of 0. Much easier, but be careful. Just plugging those points in and getting your graph. All right, that's it, math fans. Have a good day.